Welcome to 32nd lecture in the course of Industrial Engineering and Operations Research. Mainly we are now discussing operations research portion, and in that operation research also we are discussing very important topic of linear programming, in which objective functions and constraints are linear in nature. So, in the last class I discussed that how we can formulate a linear programming which is called LP problem, how we can formulate a problem, and today in this talk we are going to tell one method which is called graphical method. That means by drawing some diagram we can find out the solution of the problem. But this method will work only if there are two design variables, or maybe you can say one design variable also, one or two design variables. Anyway, one design variable problem is anyway very easy. So, hardly any book gives any example of one variable problem, but two variable problems are given in the textbooks and we need to solve it by graphical method. But this method will not work if there are more than two variables. Suppose there are three variables, then you cannot draw a 3D picture properly. That is why if you can draw 3D, then perhaps the method can be used for 3D also, but naturally the 4D will be almost impossible. But this method, then why are we studying? Because first of all, for two variable problems it will work, some problems may be two variable problems also, and second thing that we will get insight, that insight can be helpful in understanding the other things. So, let us discuss the graphical method, and to understand it properly, why not we just understand from some example. So, example is like this: a manufacturer produces two types of products, 1 and 2. I have named 1 and 2 at production levels of x1 and x2. That means the quantity of the product 1 is x1, okay, and quantity of product 2 is x2. So, x1, x2 are the quantities of the products. We want to understand that how much quantities we have to produce. So, naturally these are decision variables of interest, and the profit is given as 2x1 plus 5x2. That means you can say maybe by selling 1 unit of x1 I get 2 rupees or 2000 rupees, and by selling x2 we get 5000 rupees. Okay. So, maybe 1000 I am not writing, I can write 2x1 plus 5x2. I mean to say that unit you adjust yourself whether it is $2, 2 rupee, 2000 rupee, but this is how that the objective function is that our objective function is maximize profit. So, 2x1 plus 5x2, and the production constraints are x1 plus 3x2 is smaller than 40. How we got the production constraint? Maybe these products may require some raw material, and suppose for making 1 unit of product 1 you need 1 kg of some resource. Okay. So, we have x1, and maybe if we use 3 and making 1 unit of x2, that same resource is needed in 3 kg. So, x1 plus 3x2 will be the total expenditure of that resource, maybe which resource can be called R1. So, that maybe it should be less than 40 because we may have only 40 kg in the factory. Similarly, the other resource R2 is available in 24 kg, but 1 unit of x1 needs 3 kg. So, 3x1, and 1 unit of x2 needs 1 kg. So, x2, so 3x1 plus x2 is smaller than 24. And of course, x1 must be greater or equal to 0, x2 must be greater or equal to 0. We cannot obtain any solution in which one quantity is negative, because theoretically in mathematics we do get answers that something is negative, but here you cannot have a negative quantity production, it has to be positive. So, therefore, x1 greater than 0, x2 greater than. Now, the question is that using graphical method find out the production level, that means you find out x1 and x2 in order to maximize profit and what is the maximum possible profit. So, how to go about that? So, now one thing I must tell that this we can solve graphically because there are only two decision variables x1, x2. So, easily I can make one maybe two dimensional coordinate geometry type thing I can use, and I can show in the x axis x1 and in y axis vertical axis x2. So, here we can say x1. So, any possibility is shown in this space x1, x2. If I put that thing, any coordinate tells me x1 and x2. So, that way we are able to solve, and how many constraints are there, that is not very much important. Even if you have 20 constraints, then also I can solve it, even, but here you have got only 2 constraints. So, do not misunderstand that it is only applicable for only 2 constraints. It can be used for any number of constraints. Constraints is not a problem. Only thing, decision variables cannot exceed 2. Okay. So, let us try to solve that problem. So, how do we go about that? See, one constraint is that 3x1 plus x2 is smaller than 24. You just see, sorry, 40. 3x1, sorry, this is x1 plus 3x2 is smaller than 40. So, x1 plus 3x2, in fact, the constraint was x1 plus 3x2 is smaller or equal to 40. So, we draw a line whose equation is x1 plus 3x2 is equal to 40. How should I draw a line? A line, if you specify 2 points, you can easily draw a line. So, therefore, what do you say that? What you will do, that you put, suppose you put x2 is equal to 0, then x1 is equal to 40. That means you choose a point here in the x axis that is at 40. So, we have taken that point. Similarly, when we make x1 is equal to 0, then x2 becomes what? 40 by 3. That means 13.33. So, this point at 13.33 I marked at here, and I have written it like B. I have marked this also, and then I join this line. Okay. So, this line, when I joined, this line has become x1 plus 3x2 is equal to 40, that line. And but my coordinates have to be less than 40. So, that means you have to be towards this side of that. Okay. Like this side. Okay. That means you are not allowed to cross this line. This line becomes a border type of thing, and you can do towards origin side of this one. How do you assess that it is not this way? Means you may think that this is the boundary, but why should I not be this way? Because as you know that suppose you put x1 is equal to 0 and x2 is equal to 0. So, 0 plus 0 is less than 40. So, this is feasible. So, therefore, 0 and 0 should be on this side. Okay. So, therefore, it is obvious. Also, you say that as far as suppose x2 is 0, x1 is equal to 40, anything less than 40 will also be acceptable. Suppose x1 is 35, it is satisfying, and x2 is 0. So, it is satisfying everything. So, that means it is this side. So, you have to be this side. Similarly, draw the another line, that is 3x1 plus x2 is equal to 24. Rather, other constraint is that basically 3x1 plus x2 is smaller or equal to 24. So, we draw a line whose equation is 3x1 plus x2 is equal to 24. How we will draw that? Same procedure. Put x2 is equal to 0, that means x1 is equal to 8. So, in x axis it cuts it at 8. So, this is the 8. I have marked it as a point, this one A. And similarly, when x1 is equal to 0, x2 is equal to 24. So, this point is 24. So, with these 2 points, you draw the line. So, again, it is less or equal to 24. That means you can be less than 8. That is, or you can be less than say 24 here in the vertical axis, that means basically you are this side, okay. Of course you are this side because you put x1 is equal to 0, x2 is equal to 0, 0 plus 0 is less than 24, which satisfies. So that means we have to be this one. So now you have common region, that you know there are two constraints. One constraint says you cannot cross this line, you cannot cross this line, this is the one line. Another constraint says you cannot cross this line, okay. So together will be basically the intersection of both the things. Common region for both the constraints is only this. So this is what that you will get region, which is, you know, that by the hatched blue lines. In this region you can be there, anything can be taken like that. But here we can easily prove, and also we can observe that it is a totally convex region, it is called convex hull, and the solution will be in any of the kernel, okay, any of the kernel. Definitely the solution can, because kernel is the farthest point, okay. So now how do we do that? So there are two type of methods, okay. Now profit is 2x1 plus 5x2, okay. Now what we can do that, we know that the solution can be any kernel, and there are 1, 2, 3, 4 kernels, and profit is what? Profit is basically, profit is 2x1 plus 5x2. So we can evaluate this profit at all the 4 points, and we can see that which gives the maximum. So naturally at 0, 0, if we put x1 and x2 0, profit is 0. That means you are not doing any production. So that point is basically gone. You don't have to worry about that. If I go at this kernel, that means I just produce x1 only, you will get 16, okay. So basically I could say ZA is equal to 2 into 8, because x1 is 8, plus 5 into 0 is equal to 16. ZB is equal to 2 into 0, because here B this point 2 into 0, x1 is 0, but this is 40 by 3, 5 into 40 by 3, so 66.67. And ZC, how do I find out ZC? For that, because this is, we have to solve these two equations, 3x1 plus x2 is equal to 24, x1 plus 3x2 is equal to 40. So intersection of these points, you solve these simultaneous equations and you get basically this one point C. So this point C has come, and C's coordinate is 4 by 2. I just solved two simultaneous equation, you know it very well, therefore I am not, you just solve that this one. So this will be intersection point, 3x1 plus x2 is equal to 24. It is taught in class 7, 8. You just solve this and you get that thing. But I got the point 412. I can check that whether this is the correct solution or not. If you put x1 is equal to 4, 4 plus 3 into 12, 36 is equal to 40, correct. And this is 4 3s are 12 plus 12, 24. So we got 412 and we calculate the profit at that point. So 2 into 4 plus 5 into 12 is equal to 68. So maximum profit is 68 at production levels of x1 is equal to 4 and x2 is equal to 12. So that means we should make 4 quantities of product 1 and 12 quantities of product 2. So we got the solution. That is one way of doing that thing. Other way could have been that I know that my profit, that is profit is 2x1 plus 5x2. So suppose I draw some line parallel to this 2x1 plus 5x2 is equal to some profit, okay, which may be some constant term, and you can take any value of that profit, that doesn't matter. So here suppose I say, let us say 2x1 plus 5x2 is equal to, let us say that simply suppose instead of profit, suppose it would have been 10. Then what it would have been? x1 is equal to 5, that means one point is something here, and x2 is equal to 2, okay, 2 is like this. So it would have been something, some this type of line, okay. So that means we can draw many lines parallel to this, and in that only 2x1 plus 5x2 will be same, only the p value will be changing. Instead of 10 there will be something. So, I keep doing that, and draw. So, one parallel line will pass through B, but another will pass through C. After that there will be another parallel line, but it is in feasible region. So, in the feasible region this parallel thing only cuts it at C. So, that means C is the farthest point. Okay. So, C is the farthest point. So, therefore, this one, that means C is the point we have understood, because this is also nearer to this one origin, but this is the farthest point. So, that way we can know that yes, my solution is this, and we can know that once we have known that C is the point, then we can find out the coordinate. So, this is another method of doing that. That means, if you have got a mini drafter, so mini drafter you can draw parallel lines parallel to the objective function line and see that where it cuts. Okay. Now, let us see that here once we have got the solution. So, we got the optimal solution as 4 and 12, and now we substitute in both the constraints. So, in the first constraint, now suppose we put that x1 plus 3x2, 4 plus 3, 12 is equal to 40. So, left side equals the right hand side, so constraint is active. That means, this constraint is fully satisfied. That means, it is equal. We are at the border case. So, this is called, this is an active constraint. It is having influence. You cannot ignore that constraint. If you slightly change the values, this constraint may be violated. Second constraint, 3x1 plus x2. You put that 3 into 4 plus 12 is equal to 24, and right hand side was also 24. So, left hand side equals the right hand side. This constraint is also active. We also have non-negativity constraint x1 greater than or equal to 0, but we got value 4. So, 4 is far ahead 0. That means, it is not at the boundary. Okay. Even if you have slightly changed, 4 becomes 3 also, does not happen anything. So, therefore, this is inactive constraint. Similarly, x2 is equal to 12. This is an inactive, because 12 is much bigger than 0. So, even if I would not have said that x1 greater or equal to 0, it would not have made much difference. That means, you are quite far away from the 0 side. Okay. x1 0, x2 0. So, C point is quite far away. So, does not matter, as if that x1 and x2 equal to 0 do not exist at all. This is, that's why this constraint is inactive type of constraint. Okay. So, this is also very important. Now, we can calculate the unit worth of resource for constraint x1 plus 3x2 is smaller than 40. Unit worth of resource means that if we increase one quantity of the constraint, how much quantity of the objective function changes. So, suppose we increase 40 to 41 and solve the again that one LP. Suppose we have maximized 2x1 plus 5x2, and then subject to this one 3x1 plus x2 is equal to 24, and if we would have solved it again, then we would have got solution x1 is equal to 3.875. You can try to solve that. We know that the solution is at point C only. So, we can just solve that 41 and 3x1 plus x2 is equal to 24. We just solve it and we get x1 is equal to 3.875, x2 is equal to 12.375, and maximum profit, if we put in the profit equation 2x1 plus 5x2, we get z is equal to 69.625. So, unit worth of resource for constraint, this constraint is what? That what is the new profit, what is the original profit. So, new profit is 69.625, original was 68. So, 1.625. That means, if I increase this value by 1 unit, constraint becomes 41 from 40, then I get a gain of 1.625 rupees. So, therefore, unit worth of resource of that constraint is 1.625. And similarly, unit worth resource for constraint this one 24. So, then we increase this by unit 1 and solve this problem 2x1 plus 5x2. This will remain same 40 only, but this will become, instead of 24 it will become 25. Again we solve and we get 4.375 and x2 becomes 11.875 and maximum profit becomes 68.125, and therefore unit worth of resource of constraint 3x1 plus x2 is smaller than 24 will be new profit minus original profit is equal to 68.125 minus 68 is equal to 0.125. And what is the unit worth of resource of inactive constraints? Unit worth of resource of inactive constraints is 0 whether you increase. Suppose if I would have given constraint x1 greater than 1 instead of 0, then how the answer would have changed? Answer would have remained same. X1, see, if you would have given x1 should be greater than 1 instead of 0. So this that means you should have been in this region. So doesn't matter. So that is what this one it will be. So as I mentioned already that there are two graphical solution methods. One is called extreme point method. Extreme point method focuses on evaluating the objective function at the kernel points which are called extreme points of the feasible region. So I evaluated, you see that I explained you through extreme point method A, B, C at all these points at all kernels I calculated the value. Other is that iso profit method, that where we made iso profit line, okay, 2p is equal to 2x1 plus 5x2 is equal to p is iso profit line. So iso cost method or iso profit method involves drawing lines representing the objective function and moving them to find the optimal solution. That you can do with the help of a mini drafter or set square, and you can do that solution. So now we can get more confidence by solving one or two more problems. So suppose solve the following problem graphically. Maximize z is equal to 4a plus 2b subject to a minus 2b greater or equal to 2. That is greater than or equal to inequality, and a plus 2b is equal to 10, that is an equality, and a minus b is smaller than 13 and a, b both are positive. So you see that there are three constraints and three are of different type. One is equality, another is less than or equal, and another is greater than or equal type. Now what happens that this is, so first we can solve that, okay, let us see that we just solve that. So how do we solve that? We draw that, we say that suppose this is A and this is B line, okay, using that open source software. I just have made the graph from there, okay. You can use that some site like math-a2z.com, and then you can find out. So suppose we have a plus b, a minus 2b greater or equal to 2 and a plus 2b greater than 10. I think that a is equal to this one, a minus b is smaller than 10, okay. So what happens that, let us see that how we can draw. A minus 2b is equal to 2, that means if b is equal to 0, a is 2. So this is what, that this is a minus 2b, a minus 2b equal to 2 line, and this is 2, and a minus 2b greater than 2, okay. So that means you have to be this side, okay, that means you have to be this side type of thing, you have to be this side, okay. And b is equal to, basically of course that if a is 0 to b becomes minus 1, so that means b is minus 1. So if you extend it by that side, you will get that this one, okay, if you extend that thing, but in the graph I have, so this is a line a minus 2b, you have to be this side. Another is a plus 2b is equal to 10. So one thing is a is equal to 10, okay, and so we have to put it here, and a b is equal to 5. So we draw it, so this becomes, this line becomes a plus 2b is equal to 10, and so this is rigid, okay. You cannot say that you go this way or that way, like you cannot have this region, or you have to be on this line. So therefore only all the points which lie only on this line in positive quadrant, only they are feasible. So this cuts it here, okay, that means this cuts it here. So therefore obviously that we can have here this point is also feasible, because this is, you have to be this side about that, a minus to be, and but you can have like this. And then a minus b is smaller than 13. So a is smaller than 13, so a is equal to 13, and b of course becomes a minus 13. So that means, or you can say a minus b, it is a line at 45-degree angle. So 45 degree you have drawn, and but a minus b is smaller than 13. That means you have to be this side. Okay, so this side everything is feasible. Okay, so you get a feasible zone. Now your feasible zone is basically common thing is only this much. Only this much you can have this one. So therefore you have got these things, and now you find out the solution. Okay, so you can have intersection of these 2 points, that these 2 lines gives you 6 and 2. So at that point your profit was 4a plus 2b, profit becomes 10, 0. And also if you put that, suppose you would have taken this point 10 and 0, then also it would have been your profit. Okay, so you are actually getting many solutions. Okay, that means this point corner is also this one, and this corner is also a solution. I said corner is this one, but if 2 corners are the solution, then line joining them, if they are adjacent, then line joining them will also be solution. Okay, so all the points are the solution of this problem. So that's why it is happening that here in this case it is 4a plus 2b and it is a plus 2b. So both constraint and this objective function is parallel. If you do by mini drafter method, that means iso profit line, then you can say that this is basically the same equation, 4a plus 2b. So 4a plus 2b is equal to 10. Okay, and this is 4a plus 2b. Okay, so here that is 10. Okay, no, but one thing here, that here let me just see it again, that solution. Okay, this point is 10 and this is 0. Okay, and profit is equal to 4a plus 2b. Okay, so here, and this is of maximizing that. So therefore at optimal here you have, so here you have 1.62. Okay, so this is 62 and this point is basically 10, 0. So at 62, it's at 62, that means at this black one, you get a profit is equal to 6 4s are 24 plus 8, that means 32. But here at 10, 0, you get P is equal to 4 into 10 plus 0. So this is 40. So you don't have multiple solution. You have only one solution. Here it is given as this one, 10, 0. Okay, so that is the optimal solution you have obtained by this one. So blue line is a plus 2b, solution has to lie on it. I am just summarizing. There are 2 cardinal points, red point a 10, 0, black point a is equal to 6, b is equal to 2. Function value on this point are 40 and 28 respectively. You can calculate. I have calculated slowly. Hence the optimum solution is 40 with a is equal to 10 and b is equal to 0. Now for general case, for first point, that is a is equal to 10 and b is equal to 0, we can say z is equal to 10x, and for second point I is equal to, suppose your profit would have been xy plus x, this was given here. If we would have been a general solution, that is x1 is equal to, where was that thing? Yes, z is equal to xa plus yb. In that case, I have argued that function values on this point, for general point, it would have been general case, first point z is equal to 10x, and for second point z is equal to 6x plus 2y. So as the first point is maximum, if you put the condition that till what range of x and y, this solution will be valid only at that point. So we have to say 10x is greater or equal to 6x plus 2y, and by solving that we can get that this is the range x by y, as long as x by y is greater or equal to 1 by 2, then the same thing will give a solution, same point will give a solution. So this is called range of optimality. Range of optimality is 0.5 to infinity. So like that we can solve this one. In fact, you can have open software also for making graphs and even solving the problem. If you give that a to zmath.com, it can give you the solution in the computer. Maximize 2x1 plus 5x2, x1 plus 3x2 is smaller than 40, 3x1 plus x2 is smaller than 24, x1 plus x2 is smaller than 10. Actually x1 plus x2 is smaller or equal to 10 and x1. So you draw these lines. These lines have been drawn, 3 lines, x1 plus 3x2 is smaller or equal to 40. This is this line. This is first constraint, x1 plus 3x2 is equal to 40. Another one is that 3x1 plus x2 is smaller than 24. So that means x1 is equal to 8. This line, I think 3x1 plus x2 is equal to 24 type of line. Okay, x2 is equal to 24. Okay, so this is not okay, this is not that one. This is x1 plus x2 is smaller than 10. x1 plus x2 is smaller than 10, because basically this line is x1 plus x2 is equal to 10, because you see 10 here, 10 here. And another one is x1 is equal to 8, 3x1 plus x2 is smaller than 24. Okay, that means this is 24. So x1 is equal to 8, x2 is equal to 24 to this line. So everything you have to be towards 0 side. Okay, feasible region. So common region for everything comes out to be this, and these are the corners. At these corners you can calculate the value. So now these at extreme points you calculate the values of objective function and find out that value is maximum at 0, 10. Okay, so this is the thing it is given. Now these are very obvious type of problem I just made. You will not find in any book. Say maximize w is equal to 4y. Suppose we have 1D type of situation. Then what to do? Subject to y is smaller than 1, y is smaller than 3, y is unrestricted. Graphically you can make that. Naturally that you have to maximize. So y has to be smaller. So you draw some line in the real axis. Suppose this is y, only one axis y. So this is y is smaller than 1, means you have to be below 1, and this is y is smaller than 3. So you have to be this side, but common region is you have to be basically smaller than 1, and therefore you have to maximize. So at most you can put y is equal to 1, and therefore the value is w is equal to 4. You cannot have other side, you have negative values and you have this one. So that means you even into 1D problem you can make that. Minimize w is equal to y1 plus y2 subject to these type of constraints, y1 plus 2y2 greater than 2. So here also you can make these constraints, but here they are of greater than type. So suppose y1 plus 2y2, how should I make that? y1 plus 2y2, that means y2 is equal to 1 and y1 is equal to 2. Okay, so maybe this point. Okay, this is y1 plus 2y2 is equal to 2 line. Other is y1 plus 3y2. Suppose y2 is 0, then y1 is equal to 3. So this line is y1 plus 3y2 is equal to 3 line. You can draw this line. It is just question of drawing the line, but it says that you have to be, it has to be greater than 2. That means feasible region is this side. Okay, and y1 is greater than 6. Okay, so feasible line is this side. Okay, so that means you have to be this side. Similarly this fellow says that you have to be this side, and this says that y1 greater than 6. So y1 is equal to 6 line is this. That means it says that you have to be this side. So therefore obviously that feasible region will be towards this side only, but I have to minimize. So minimum, so you have got only one corner point here. So minimum extreme coordinate is basically 6, 0, and minimum value of the objective function is z is equal to 6. it occurs at the extreme point 6, 0. So hence the optimal solution is x1 is equal to 6, x2 is equal to 0, and it is equal to this one. Similarly, of course, we can have graphical solution of this one, say maximize z is equal to 2x1. Here I have given the graphical diagram also, and I am asking the question, is there any redundant constraint in this problem? So by seeing that, we can see that suppose even if this constraint would not have been there, this constraint number 1 which I have marked here, then also it would not have affected my solution. So you can say that it is redundant constraint. Okay. Then what is the value of the optimal solution? So we at the kernel point we have these values. It is given that this is the optimum solution. You can put, you just have to put the value, and you are the coordinates. It is said that suppose you calculate the value here and you calculate the objective function at this point, both are giving the equal answer. So therefore these two are the solutions, but any line joining these two will also be solution. So what will be the x1 general solution is alpha times 2 plus 1 minus alpha 1 times 0. So this is x1 is equal to alpha time 2 and 1 minus alpha time this one, and x2 is equal to alpha 2 by 3. Okay. So it is equal to this one. Okay. Instead it will be rather this one. Okay, you have to be careful. If there are 2 points, that is 2, 0. 2, 0 means, is it the point is that this one? Okay, the linear constraints are this one. So what happens that here you have to consider that alpha times 2. Okay, that is alpha times 2, that is one solution, plus 1 minus alpha times if 2 by 3, 0. So it is 2 by 3, but first let us check that objective function value is correct or not. 2 by 3, 2 into 2 by 3 plus 8 by 3. So this becomes 4 by 3, so 12 by 3. So that means basically 4, and at 2, 0 also it is 4. So your solution will be given by this. Okay, not by this way. The solution will be given by this one, alpha times, you can say 2, 0 plus 1 minus alpha times 2 by 3 and 8 by 3. So x will be alpha 2 and plus 1 minus alpha 2 by 3, like that, and this will be alpha into 0 and 1 minus alpha 8 by 3. So this is how that it does. Okay. So I think that I should stop it right now, this discussion on graphical methods here, and we will be little bit time to time we will again go back to this graphical method, and in the next class I will teach you simplex method. Okay. Thank you very much for your kind attention.